Alright, so this is my 8 puzzle. I'm going to run BFS on easy, A star 3 on medium, and A star 1 on hard. So it looks like BFS on easy finished, A star 3 finished on medium, and A star 1 is currently working on hard. So as you can see, it looks like the hard one just finished. For BFS, it's got a total cost of 17. It shows you each step what the action is. The medium for A star 3 took a little bit longer, and then A star 1 takes a little bit longer there. So I'll start and show how I modeled everything. The state is a two-dimensional array, but I pass in a 1D array from the main function here, and then it generates a 2D array and stores it in the current state. I also have a field that keeps the coordinates of the I and j values for the 0, or the whole, I guess. And then I have a node class which does the successor function. So it generates the left, right, up, and down. So in here, all it really does is grab that I or j value from the state, and then subtract 1 or add 1 to the j value for left or right, and then to the I value for up or down. And then I guess we could start with breadth first. In here, this is the main loop, and you can see that I'm adding to the queue, which is a linked list, and then I use a hash set to check the visited nodes. Here I store that in a boolean called contains, and I check that before I run, and then add it to the queue. So then we can move to depth first, which is pretty similar to breadth first, with the one exception of adding to the queue in the front of the queue. So instead of adding to the back, you add to the front for depth first. Then we can go over iterative deepening. Here I originally had a recursive approach, but I had to rewrite it for an iterative, starting to issues there. So here I just loop over all the depths, and then I run DFS on each depth, and I add to the queue at the beginning, and I check if it has been visited and if the child's depth is less than the depth passed in. So I'm only checking at that depth, and then I can see if that child is a goal node. And then I have uniform cost search, so this is using a priority queue, which checks the path cost, and then in here I add to the priority queue, and then it gets sorted out by the path cost comparator, which I use, and then it orders it by least cost to most cost. And then we can move on to A star 1. So this is going to use the A star 1 heuristic that I created. So this is the misplaced tile count plus the path cost. And there it just adds to a priority queue, and uses that A star 1 heuristic to sort the values in the priority queue and pop them off the queue for the least, the amount that's least in that priority queue. So A star 2 uses Manhattan distance plus the path cost, and that works in a similar nature. You're just popping off the queue for the least value that's stored on that queue for each node. And then A star 3, which I did Manhattan distance plus the path cost plus the misplaced tile count. So that should be it for 8 puzzle.